If you made a perfect copy of a living animal, the same cells, the same code, the same face, would the copy begin its life already old? It sounds like a question for a child or for a science fiction film. But for one animal in one low gray building in Scotland, it stopped being a hypothetical and became something the whole world believed it already understood. The animal was a sheep, and the answer everyone settled on turned out to have almost nothing holding it up. For years, one idea followed her name wherever it traveled, that she had aged too quickly, that the way she was made had quietly cost her, that she was living proof of a hidden price for tampering with life. It appeared in newspapers, it worked its way into textbooks. It became one of those facts that everyone simply knows without ever having read the study behind it. And then, more than a decade after she was gone, a small group of researchers did the one thing almost nobody before them had bothered to do. They went and checked. What they found didn't gently revise the story. It removed the ground the whole story had been standing on. She was born on the 5th of July, 1996, at the Roslin Institute on the edge of Edinburgh, and for the first 7 months of her life, almost no one outside that building knew she existed. The team that made her, led by the embryologist Ian Wilmot and the cell biologist Keith Campbell, had taken a single cell from the mammary gland of a 6-year-old ewe and asked it to do something that, until then, biology had been fairly sure was impossible. Every cell in a body carries the same full set of instructions, but a mammary cell has switched most of them off. It is committed to being a mammary cell and nothing else. The Roslin team coaxed one of these committed cells to forget what it had become, emptied a donor egg of its own genetic material, and slipped the mammary cell's nucleus inside. The egg, remarkably, treated that adult nucleus as if it were brand new and began to build an entire animal from it. It had not worked cleanly. It had taken 277 attempts to produce one lamb that lived, a rate so low that, for a long stretch of the work, the more sensible prediction was that it would never work at all. But it did. She was named Dolly, half as a joke, because the cell that built her had come from a mammary gland, and the researchers could think of no more famous one than Dolly Parton's. When the announcement finally came, in February of 1997, she became, more or less overnight, the most famous animal on the planet. The first mammal ever cloned from an adult cell, and proof that a fully grown, fully specialized cell could be wound all the way back to the start. The reaction was enormous, and not entirely calm. She was on magazine covers and the evening news. There were sermons about her and parliamentary hearings, and a sudden global argument about where all of this would end and whether it should. And yet to look at her, standing in the straw among the other ewes, you would never have picked her out. She was an ordinary Finn-Dorset sheep, thick cream fleece, dark legs, a plain, unbothered face. Nothing about her body announced what she was. If you'd rather have the record straightened than the myth repeated, subscribing keeps this kind of story coming. The trouble began, as it often does, with something real. In 1999, when Dolly was 3, a study led by the biologist Paul Shields measured the telomeres in her cells, the protective caps on the ends of chromosomes that shorten a little with each division, and that tend, on average, to grow shorter as an animal ages. Dolly's were shorter than expected for a sheep her age. The finding was careful and honestly reported, and it raised a fair question, because the cell she had been built from had already lived 6 years before she was born. Had she, in some quiet way, inherited that head start toward old age? Then, as she grew, a second fact arrived to keep the first one company. At around 5, Dolly developed arthritis in a knee and a hip. On their own, neither observation proved much. A single sheep with slightly short telomeres is a data point, not a verdict, and arthritis is common in sheep, especially in one who had spent much of her life indoors, on display, growing steadily heavier on the treats of admiring visitors. But together, the two facts were irresistible. Short telomeres, early arthritis, a world-famous clone. The shape of the story was simply too neat to leave alone. And so two modest observations fused into a single confident conclusion that neither of them, alone or together, actually supported that cloning had aged her before her time. That conclusion hardened. It moved from speculation into commentary, from commentary into reporting, and from reporting into the kind of received fact that ends up in a classroom. Cloning, it was now widely understood, produced animals that aged too fast, and Dolly was the proof. It ran in documentaries, appeared in textbooks, and settled into the culture as something everyone simply knew. What almost no one noticed, across all the years the claim was repeated, was that nobody had ever actually tested it. The idea that her arthritis was premature rested on remarkably little, a passing mention, far more than a measured comparison of her joints against sheep her own age. For 14 years, one of the most repeated claims in modern biology sat entirely unexamined. There was, in the end, a great deal more written about Dolly's aging than was ever measured of it. And the claim was not a harmless one. By the early 2000s, the point of cloning had stopped being the spectacle of a copied sheep and become something quieter and more useful. Flocks bred for disease resistance, endangered animals recovered from frozen cells, herds engineered to carry medicines in their milk. If the price of every one of those animals was a body that wore out early, then the whole enterprise carried a defect written into it from birth. Cloning ages you was never just a sad footnote about one famous ewe. It was, if true, a verdict on an entire field, and it had been reached without anyone measuring the single animal it rested on. The test, when it finally came, was almost ordinary in its method. In 2017, a team led by Kevin Sinclair at the University of Nottingham realized that the evidence to settle the question had been sitting in a museum the entire time. Dolly's skeleton was held at National Museum Scotland, and so were the skeletons of 3 other cloned sheep: Bonnie, one of Dolly's own lambs, and Megan and Morag, 2 clones made before her. The bones were all there. No one had ever x-rayed them, so they did. Working with an orthopedic specialist at the University of Glasgow, they radiographed every joint across all 4 skeletons, scored the arthritis in each using the same grading system a veterinary clinic would use on a living patient, and compared the results against naturally conceived sheep of comparable age. What came back was quiet and complete. Dolly did have osteoarthritis, but its pattern and its severity were exactly what you would expect in any sheep of her age, cloned or not. There was nothing premature about it at all. The single observation that had launched a global belief turned out to describe a perfectly normal animal. There was one obvious objection left to close. Dolly had been overweight, and she had lived much of her life indoors, both of which wear down joints on their own, quite apart from how an animal was conceived. But when her skeleton was set beside naturally bred sheep of the same age who had lived the same kind of managed, well-fed life, she still did not stand out. Joint for joint, she was an unremarkable middle-aged ewe. If you want the part that reaches past one sheep, this is the moment to make sure you're following along. Because the correction did not stop with Dolly. A year earlier, in 2016, the same group had published something that might have ended the argument on its own. They had been quietly aging a small flock of clones, 4 ewes called Debbie, Denise, Diana, and Daisy, derived from the very same cell line that had produced Dolly, the Nottingham Dollies. By the time the researchers examined them closely, the 4 were between 7 and 9 years old, a comfortable old age for a sheep. They put them through the assessments you would run on any aging animal: their joints, their blood pressure, their metabolism, their control of blood sugar. Across every measure, the clones were healthy. Their arthritis was mild and appropriate for their years. Nothing about them looked like a body racing toward an early end. Put the 2 studies side by side, and the accelerated aging story fails, not at the level of one animal, where it might be waved away as a single unlucky case, but across the whole group. The sheep built from an adult cell aged like sheep. The myth had outlived its own evidence by more than a decade. Even the telomeres, the very thing that had started the worry, read differently with hindsight. Telomere length is a far noisier signal of biological age than it was once taken to be. It varies from tissue to tissue, from individual to individual, and even with the method used to measure it. The short caps found in one young sheep in 1999 never translated into the failing health the finding had seemed to warn of. The alarm had been real. The fire it predicted simply never came. So here is what remains true about Dolly once the drama is taken away from her. She was a Finn-Dorset ewe, born in the summer of 1996, the first mammal ever cloned from an adult cell, an achievement that genuinely changed what biologists believed was possible. She lived about 6.5 years. She had 6 lambs of her own by an ordinary ram in the ordinary way. She grew a little heavy and a little stiff, as sheep do, and in the winter of 2003, she developed a lung infection, a contagious disease that spreads among sheep kept close together, and that had nothing at all to do with the way she was made. It was that, and not cloning, and not some hidden inner clock, that ended her life. She was 6. Her arthritis, we now know, was simply the arthritis of a sheep her age. She stands today in a museum in Edinburgh, preserved, turning slowly on a low plinth for the visitors who still come to see her. Not a cautionary tale, not proof of a hidden cost, just a sheep, one whose body was examined more closely than almost any animal in history and found, in the end, to be unremarkable. What stays genuinely open is the larger question she could never settle by herself: whether making an animal this way leaves any faint, long-term mark that a knee X-ray and a healthy flock of 4 could never quite reveal. Cloning from an adult cell is still difficult, still inefficient, still only partly understood. The question that made her famous, does the copy begin its life already old, has a clear answer now, at least for her. The quieter question behind it is still, patiently, waiting.